because there are 3 replaceable hydrogen. So it will produce H3PO4 when it reacts with 1 NaOH. It will produce 1 water molecule will be produced, and this salt and water. So what is the salt produced over here? It will replace only 1 hydrogen from here. So NaH2PO4, NaH2PO4, and the hydrogen and OH will form water. So NaH2PO4 plus water. This is one salt. This is an acid salt. See hydrogen present over here. When this H3PO4 reacts with 2 NaOH, 2 molecules of NaOH, then it will form Na2HPO4. See, another hydrogen replaced by sodium. But 1 hydrogen is still left. This plus H2O. Again, there is 1 replaceable hydrogen. So H3PO4 can react with 3 molecules of base, tribasic. It can react with 3 molecules to give a normal salt, Na3PO4. Now all the hydrogens are replaced. Now it gives a normal salt, Na3PO4 plus H2O. Overall equations. So did you understand that? When it's reacting with 1 molecule, this is partially removed. Hydrogen is partially, means only 1 hydrogen is replaced by sodium. And when 2 molecules are reacting, then it is forming there's no overall equation over here. These are 3 steps over here, 3 types of salts that have. So sodium dihydrogen phosphate. This is an acid salt because hydrogen is present. Then in the next step with 2 molecules, it is forming disodium hydrogen phosphate. This is also an acid salt. Still there is 1 replaceable hydrogen atom. In the third step, when it is reacting with 3 NaOH, then it is forming Na3PO4 sodium phosphate, and there is no more hydrogen left over here to be replaced. So this is a normal salt and water. It dissociates in 3 steps. It produces 3 types of salts, and it is called a tribasic acid. Basicity of the acid is 3. Similarly, for bases, triacetic base like ferric hydroxide, FeOH3, aluminium hydroxide, AlOH3, furnishes 3. If it is water soluble, then it will furnish 3 hydroxyl ions. Ferric hydroxide will furnish 3 hydroxyl ions. Chromium hydroxide, CrOH3. So these are the examples of triacidic bases, or acidity is 3. Now one thing about basicity, when we are talking about basicity, do not confuse with the number of hydrogen ion. What I said is number of replaceable hydrogen ion. That, see, for example, suppose acetic acid, CH3COOH. How many hydrogen ions are present over here? CH3COOH. There are 3 and 1, 4 hydrogen ions. So it is not a tetrabasic acid. It is a monobasic acid because it dissociates CH3COO acetate and H+. So it's got only 1 replaceable hydrogen ions. It is a monobasic acid. Again, H3PO3. There are 3 hydrogen and H3PO4. Here also there are 3 hydrogen, but H3PO3 is not a tribasic acid. H3PO4 is tribasic, but this is not a tribasic acid. Look at the structure of H3PO3. Phosphorus is the central line with OH, H, double bond O. This is H3PO3. Okay, so see P, 1, 2, 3 oxygen and 3 hydrogen. So H3PO3 is not a tribasic acid. Why? Because only this hydrogen and this hydrogen, in oxyacids of phosphorus we see that the hydrogen which is attached to the oxygen atom, only that can be ionized, that can be replaced. Why? There is a reason for that. See, the oxygen is highly electronegative, and because of its electronegativity, what happens? This shared pair of electron, hydrogen has one electron and this has its own electron. Okay, so this shared pair of electron, how this is towards oxygen. This shared pair of electron is towards oxygen. Oxygen is more electronegative, so this is towards. So it is easier to break this bond, and these two only are replaceable hydrogen, and the hydrogen directly linked to the central ion, to the phosphorus, is not replaceable. This cannot be ionized, it is not ionizable. So it is dibasic and not tribasic. In H3PO4 we have OH over here, so that is also, all three are ionizable. So that is tribasic but not H3PO3. Now we will do the preparations, acids and bases. This was classification, and now we will do the preparations of acids and bases. First, by synthesis. Synthesis means direct combination. The elements are combining to form the molecule of acid or base. By synthesis or direct combination. First method, by synthesis. Only hydracids can be prepared. Binary acids can be prepared. Binary acid means the acid which contains only two elements, like say HCl, HBr, H2S, HI, all that. So H2 plus Cl2, direct elements are directly combining and the acid is forming. That is 2HCl. Then H2 plus S, so hydrogen is passed through molten sulfur, H2S. So this is direct combination or synthesis. Next is, how are the bases? Bases are metal oxides or metal hydroxides or metal oxides, you know that. So metal oxides can be, metal can combine with the oxygen, suppose magnesium ribbon burns in oxygen. So directly Mg plus O2, 2 Mg plus O2, 2 MgO, or say sodium. Sodium is taken out from the kerosene and is kept in the air. It directly combines with oxygen and forms Na2O. So this is direct combination. The metal combines with oxygen and forms the metal oxide, the base. So this is one method. Next is acidic oxides when dissolved in water. Acidic oxides and water. Acidic oxides or non-metallic oxide. Acidic oxides. Now all non-metallic oxides are not acidic oxide, like carbon monoxide. All non-metallic oxides are not acidic oxides. So how? Like say NO or CO, nitrogen monoxide or carbon monoxide. These are neutral in nature. So they do not form acids. So acidic oxides like say SO2 plus H2O, CO2 plus H2O, or SO3 plus H2O. These P2O5 or N2O5. They form the respective acid. SO3 will form sulfuric acid, H2SO4. SO2 will form sulfurous acid, H2SO3. Carbon dioxide will form carbonic acid, H2CO3. P2O5 will form phosphoric acid. N2O5 will form nitric acid. this is 2HNO3, and this will be, this is 3H2O, 2H3PO4. So phosphoric acid, nitric acid, carbonic acid, this is sulfurous acid, and this is sulfuric acid. When these acidic gases are dissolved in water, they furnish these acids. So these are also known as acid anhydrides. Means if you are asked a question that what is the acid anhydride of sulfuric acid, then the answer is sulfur trioxide, not dioxide. Okay. So acidic anhydride, these are the acidic anhydrides of the acid, these acids. Okay. Acid anhydrides. And this is what when non-metallic oxides are dissolved in water. When metallic oxides are dissolved, or hydroxides are dissolved in water, then what happens when metallic oxides are dissolved in water? So this Na2O or K2O plus H2O, what will it give? This is the second one. So what will it give? It will give NaOH. It will form NaOH, because the soluble, all metal oxides are not soluble, very few metal oxides are soluble in water. So if it is soluble in water, then it will furnish what? The hydroxide. NaOH will be formed. And if we directly add the metal to water, then also NaOH can be, NaOH is furnished. Means the sodium metal is directly dropped in water, then also sodium hydroxide and hydrogen is formed. NaOH plus H2. This will be formed. Okay. So